Hello students, welcome to today's class. Today I'll be discussing the multiple choice questions on the chapter thermodynamics, that is from first year PUC. So let's go to the questions one by one. A state function is one which depends on the initial and final states of the system. See, this is the definition of the state function. See, if there is a matter taken in a cylinder, it has certain pressure, it has certain volume, it has certain temperature, it has certain mass or number of moles. See, this does not depend upon the history of the system. How we arrived at this system is not important. Again, if after some process, there will be change in the properties of the system, like pressure, volume, temperature. Some of them may remain constant or all of them may change depending on the process. Then we say it is final P2, V2, etc. So again, the, how we arrive at this is not important. It is like understanding that you are in Tumkur and here the temperature is about 25 degrees centigrade. Today, whether you come from Mysore or whether you come from say Hubli or whether you come from Chennai, so it does not matter. So always the temperature remains same at 25 degree centigrade. So whatever the place you begin is not important. So that's what we say. So your history of arrival, Tumkur, is not important. Its temperature, its atmospheric pressure, its humidity conditions. So all remain same for different persons who arrive from different places. So it is independent of the initial and final states of the system. This is the wrong statement. It is path dependent. Path dependent means it does not depend on the initial and final state. It depends upon the process that is chosen. So process becomes important, whether it is isothermal, adiabatic, isophoric. So that type of process becomes very important. Therefore, it is not the definition. Depends on the mass of the system. So the mass of the system has nothing to do with the temperature or the pressure or the volume in case of say solids and liquids. Therefore, so it is not a completely correct statement. Therefore, you have to consider the option A as the answer. So, correct definition where a property, a measurable property, which depends on the initial and final states, not on the history of the system. Which of the following is not a state function? See, pressure, if you look into a state, say pressure is about 1 atmosphere, say volume is 1 liter, say temperature is about 300 Kelvin, and say it has got certain enthalpy. Enthalpy is because of its mass, its internal energy, again because of the mass, its temperature conditions. So all these, they do not depend upon the history. So all these are state functions. They do not depend on the history of the system. Where heat exchange during the process depends on the type of process. It is called path dependent function. So type of process is important. How it reached from initial state to the final state. So what type of process is there? An isothermal process, or it is isobaric process, or isophoric process, adiabatic process. So how it reached that system is important. See, it is saying like this: so you travel from Mysore to Tumkur. So how you arrive determines how much time is consumed, how much cost that may have to spend. You may come by, say if you have a helicopter, you may come by helicopter, or you may come by train. So you train road, or you may catch a bus and come. The cost on the time and or you may come by say bicycle. You may do a cycling, so bicycle or you may come by walk. If you want, you may take a walk. So ಎಲ್ಲದಕ್ಕೂ ಒಂದೇ time ತಗೊಳ್ಳಲ್ಲ. So how much you energy you are going to spend depends on how you travel from Mysore to Tumkur. So ಅದೇ ತರನೇ heat exchange and done during the process are called path dependent functions. There are two path dependent functions. One is the heat exchange and also work done. They are called path dependent functions. So they are not state functions. So answer for this is again A. So the following quantities are extensive except the extensive quantity is proportional to mass. So it depends on the total quantity of the matter. If the quantity decreases, the value also decreases. The enthalpy, entropy, they all are depending on the mass of the system. In volume also depends on the mass of the system. Whereas molarity, say if you prepare 1 liter of a solution or 100 ml of a solution, or you may prepare say 1000 liter of a solution having same molarities, say 1 molar solution of oil. So all of them have the same concentration, 1 mole. See here, it depends on two extensive properties. One is mass and another is volume of the solution. So both are extensive properties, and usually a fraction of two extensive properties will be an intensive property. So molarity does not depend upon the quantity of the solution, depends upon the number of moles of the solute. Therefore, it can be considered as an intensive property. Mercury in a thermometer represents what? So in a thermometer, how it works? Thermometer contains a column and there is a bulb in which mercury is filled. So when it is kept in say hot water, then mercury expands. So how mercury rises in the column? Because it expands. Similarly, if you allow that to cool, it contracts. So when it contracts, then there will be decrease in the height of the mercury. Therefore, it is exchanging the heat. So it is going into the thermometer and coming out of the thermometer through the bulb. But you cannot remove mercury or add mercury. Therefore, it is an example for isolated system. So this is an example for isolated system. In an isochoric process, so what remains constant? It is answer is actually A. Volume change is 0. Delta V will be equal to 0. If pressure change is 0, delta P, that means the work is done against constant pressure, then delta P will be 0. Temperature remains 0, it is called isothermal process. Whereas pressure remains constant means it is isobaric process. This is isothermal process. So it is isothermal process. Internal energy change will be 0. Delta U will be equal to 0. When there is no change in the internal energy means it is also isothermal process. So answer for this question is volume change 0. So in which of the following reactions delta H is equal to delta U? So you must know the relationship between them. Delta H is equal to delta U plus RT into delta Ng, where delta Ng is equal to number of moles of gaseous products minus number of moles of gaseous reactants. So gaseous reactants ಎಷ್ಟಿದೆ, moles gaseous products ಎಷ್ಟಿದೆ, subtract ಮಾಡಿದ್ರೆ ಗೊತ್ತಾಗುತ್ತೆ. If they are zero, then it will be delta H equals delta U. See, in the first case, it is solid, it is liquid, again it is a solution, 1. So there is 1 mole of the gas, therefore for the first equation, delta Ng is equal to 1 minus 0. So 1 minus 0, right? Delta H is not equal to delta U. In the second one, so there is no gas involved. The solution, again is the solution, again it is a solution here, aqueous medium, again is a solution. So delta Ng equals 0. Delta Ng equals 0 ಆದರೆ, then what happens? Delta H will be equal to delta U. So that is what the question is. So in each of the following, delta H is equal to delta U. So answer will be B. So this should be the answer. And we shall check if there are any other answers. Really 2 mole of hydrogen, 1 mole of oxygen, liquid is there. So in the third example, delta Ng will be equal to 0 minus 2. So it is 0 minus, whereas in the case last one, it is delta Ng equals 2 minus 1, okay, plus. So there is only one case where there is no gas involved, therefore it will be the answer. The value of delta H and delta minus delta U for the following. So ಇಲ್ಲಿ ನಾವು ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. Delta Ng equals number of moles of gaseous products minus number of moles of gaseous reactants. So number of moles of gaseous products ಎಷ್ಟಿದೆ ಅಂತ ನೋಡಿ. So on the product side, how many moles of gas is? 4. It is 0. Therefore, it is 4. Number of moles of gaseous reactants. So 13 by 2 plus 1. So we have to add. Now mathematics ಮಾಡಿದ್ರೆ add ಮಾಡಬೇಕಾಗುತ್ತೆ. Then it comes to by 2. It is 15 by 2. Now apply here. Number of moles of gaseous products is 4 minus 15 by 2. So ಅದಕ್ಕೆ LCM ತಗೋತಿರಲ್ಲ ಅದೇ ತರ ಮಾಡಿ 8 minus 15 by 2. That means it comes to minus 7 by 2 RT. Now you apply that in the formula, that minus delta U is equal to RT times delta Ng. So RT as a ಹಾಗೆ ಇಟ್ಕೊಳ್ಳಿ, minus 7 by 2 is the coefficient. So the L is the rating. So this is the answer. D is the answer. So D is the answer. Minus 7 by 2 RT. Let's go to the next question. the difference between heat of reaction and constant pressure. That means it is delta H. And constant volume is delta U at 27 degrees centigrade. So ಇಲ್ಲಿ ನಾವು ಕಾಲನ್ನ ಸಾಲ್ವ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. So delta H is equal to delta U plus R is 8.3 or T 27 degrees centigrade is 300 Kelvin, and then delta Ng, so 2 moles of carbon monoxide, 1 mole of oxygen, therefore it is 2 minus 1. Now you substitute here delta, the difference is as delta H minus delta U is equal to 8.3 times 300. Now, see, it is time consuming process. If you apply 8.3, then 8 and ankomadi. So 8.3 now. If it as 8, then it will be coming very close to 2,400. So the plus side, the minus and it is plus value 2,400. So the 2,400, it will be in joule. It is in joule. So then now kilojoule ಮಾಡಿದ್ರೆ, okay, you have to convert that into kilojoule, 2.4 kilojoule. So 2.4 kilojoule answer is the, so this is the answer. ಇದನ್ನ ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೋಬೇಡಿ, ಇಲ್ಲಿ ಕಿಲೋಜೌಲ್ ಇದೆ ಇಲ್ಲಿ, so that will be wrong answer. 2.490 kilojoule. So that will be the answer. See, while doing some mathematics in chemistry, you may approximate it like that. There is tumba time consuming. You can calculate the nearest answer and then conclude which is the answer. A gas expands against constant external pressure of 2 atmosphere and its volume increases by 3.4 meter. Simultaneously, the system absorbs 400 joule of heat. So it is joule of heat from surroundings. So what is the value of delta U? Okay, it is delta U in the joule. So you have to apply the first law of thermodynamics. This question is from first law of thermodynamics, where we say delta H is equal, delta U is equal to plus Q plus W, where Q is heat supplied to the system and where work is also done on the gas. So work is done on the system. But work done will be negative because it is an expansion process. Now minus Q minus W. Now it is P into delta V. What is the work done in the P into delta V? So what is delta V? It is 3.40 liters. External pressure is 2 atmosphere, 3.40 liters. And then you have to multiply this by 101 because it will be in liter atmosphere. So to convert that into joule, you have to multiply by 101, 100 and come on for it. That will be very easy. So then it becomes nearly 680. So it will be 680 kilojoule. ಈಗ ಅದನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋಣ. ಇಲ್ಲಿ ಡೆಲ್ಟಾ ಯು ಇಸ್ ಈಕ್ವಲ್ ಟು how much heat it has absorbed is 400 joule minus of work done, that is 680. So it comes to minus 280. Now ಇಲ್ಲಿ 280 joule ಯಾಕೆ ಬರ್ತಾ ಇದೆ ಅಂದ್ರೆ ನಾವು ಇಲ್ಲಿ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ ಮಾಡಿ 101 is 100 So to save time, our multiplication easy ಆಗುತ್ತೆ. Now very close answer minus 286 joule. So B will be the answer. Because it has gained some heat, some of the heat is lost in the form of the work. So it will be less than 400 joule. It will be minus 286 joule. So this is from first law of thermodynamics. Which of the following reaction is exothermic? Now this is enthalpy of atomization. You can see a molecule is broken into atoms. So this is enthalpy of atomization. It is an endothermic process. You have to supply heat to break the bonds. Calcium carbonate decomposition, it is also an endothermic process. Usually decomposition reactions are endothermic reactions. See, this is an acid-base reaction. Sodium hydroxide with an acid gives salt and water. So it is called neutralization reaction or acid-base reactions. Neutralization or acid-base reactions are always exothermic. Really, avaglu heat to liberate aಗುತ್ತೆ. So it will be exothermic reaction. The last one is reverse of glucose formation. See, it is endothermic process, combustion, reverse of combustion of glucose. Combustion reactions are exothermic reactions, but it is the reverse of combustion. So it will reverse it will be an endothermic. Combustion is exothermic, but reverse of combustion reaction is endothermic. So large amount of heat is contained in the form of glucose. So it's two reactions, only neutralization or acid-base reaction. Now that is the C. Of course, that will be the answer. So that will be the exothermic reaction. Acid-base reactions and combustion reactions are always exothermic reactions. 1 mole of an ideal gas expands in a vacuum. See, expansion in vacuum, there is no work done. W is given as minus P into delta V, where P is external pressure. If the internal pressure is equal to external pressure, then we say it is isobaric process. But P external is 0, means W is 0. See, no work will be done, and there is no opposition. All opposition is work done upon. Therefore, it will be always 0. It will be the answer. In which of the following equations enthalpy change at 290 Kelvin or not atmosphere to the standard enthalpy of formation of methanol? The standard enthalpy of formation of a substance is enthalpy its formation from its elements. So the elements in our weapon, how standard state is it? So from the elements which are in standard. So standard elements. See, if you look at the third equation, methanol liquid standard state, oxygen O2 standard state, H2 gaseous standard state, graphite Gr the graphite. So that should be the answer. This will be the answer. ಇಲ್ಲಿ diamond ತಗೊಂಡಿದ್ದಾರೆ, therefore D is not the answer. Here it is not obtained from the elements, therefore it is not the answer. The 4H ಅಂತ mention ಮಾಡಿದ್ದಾರೆ, which is not the standard state of hydrogen. Therefore even A is done, not the answer. Therefore answer for this will be C. So C ನಲ್ಲಿ correct ಆಗಿ elements ಇಂದ methanol formation ಆಗಿದೆ. Enthalpy changes for the two reactions are given by the equation. ಇಲ್ಲಿ Cr2O3 formation ಕೊಟ್ಟಿದ್ದಾರೆ ಮತ್ತೆ ಕಾರ್ಬನ್ ಮಾನಾಕ್ಸೈಡ್ formation ಕೊಟ್ಟಿದ್ದಾರೆ. calculate the enthalpy change for the reduction of chromium sp oxide into chromium. So ಇದನ್ನ ನಾವು ಎನರ್ಜಿ ಇಕ್ವೇಶನ್ ಅಪ್ಲೈ ಮಾಡಿ ಮಾಡಬಹುದು. ಡೆಲ್ಟಾ H is equal to HP minus HR. ಇದನ್ನ ಅಪ್ಲೈ ಮಾಡಿ. So enthalpy of the products means enthalpy of formation of CO. ಇದನ್ನೇ ಯೂಸ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. Is 3 times enthalpy of carbon monoxide. Chromium enthalpy is 0. The element standard state in the carbon standard state enthalpy is also 0. So elements enthalpy bitcoin minus enthalpy of the reactant Cr2O3 matter considered matter. So it will be minus of minus. Okay, it is enthalpy of Cr2O3. Enthalpy of Cr2O3. So this will be minus 330 in the calculation, and minus of 1 minus of 1130. So it will be minus 330 plus 1130 plus 1130. Then you have to add, so you have to subtract minus 330, then it will come to 800. So we need plus 800. Yeah, the answer. This will be the answer. Plus 800 kilojoule. That will be the answer. Enthalpy changes are given at 298 Kelvin on the atmosphere for the following reactions. So NO2 formation ಕೊಟ್ಟಿದ್ದಾರೆ plus 33.84 and N2O4 formation is given. Then you have to calculate the 2NO2, N2O4. Again you apply the same rule. Delta H is equal to HP minus HR. Enthalpy of products minus enthalpy of reactants. Enthalpy of the products under N2O4. So it is enthalpy of N2O4 minus enthalpy of reactants 2NO2. So it is 2 into plus into enthalpy of formation of NO2. Because the 2 was. Now it will be plus 9.66 kilojoule minus of 2 into 33. ನೋಡಿ ಮತ್ತೆ ಇದನ್ನ ಈಸಿಯಾಗಿ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ ಮಾಡ್ಕೊಂಡ್ಬಿಡಿ. Take this as plus 10 and take this as 2 into 34. ಅವಾಗ ಬಹಳ ಬೇಗ ನಿಮಗೆ ಆನ್ಸರ್ ಸಿಗುತ್ತೆ. So 34 ಅಂತ ಮಾಡ್ಕೊಳ್ಳಿ. Then it will be 10 minus 68. So it will be 10 minus 68. 10 minus 68 and minus 58. So minus 58 is the answer. B is the answer. Minus 58 kilojoule, that will be the answer. So you will approximation ಮಾಡ್ಕೊಂಡ್ರೆ ಬಹಳ ಕ್ವಿಕ್ ಆಗಿ ಅದನ್ನ ಸಾಲ್ವ್ ಮಾಡ್ತಾರೆ. ಪಾಯಿಂಟ್ ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ಸ್ ಎಲ್ಲ ಎರಡೆರಡು ಇರೋದ್ರಿಂದ ಯು ರೌಂಡ್ ಇಟ್ ಆಫ್ ಟು ದ ನಿಯರೆಸ್ಟ್ ಹೋಲ್ ನಂಬರ್, then do the mathematics very easily and choose the answer. At 298 Kelvin, formation of calcium oxide from the elements is minus 635 kilojoule. How many gram of calcium is required to liberate 1000 kilojoule of heat? A molar mass or atomic mass of calcium is given. Minus 635 kilojoule per vector. So 635 kilojoule of heat is liberated by 40 of calcium. So of calcium. Therefore, 1000 kilojoule of heat will be liberated by 1000 kilojoule of heat is liberated by So we have to do some mathematics here. 40 divided by 635 multiplied. How 630 is ನಮಗೆ ಸಾಲ್ವ್ ಮಾಡಕ್ಕೆ ಕಷ್ಟ ಆಗುತ್ತೆ. ಅದು ನಾನು 600 ಅಂತ ಮಾಡ್ತೀನಿ. 600 you may take it as 600 and you will get the answer very easily. So skip off the zeros cancel ಮಾಡಿ. So that comes to 400 divided by 6. 100 divided by 6 means it will be very close to 66. So 66 number of the nearest answer 66 parameter. So ಯಾಕೆ ಡಿಫ್ರೆನ್ಸ್ ಅಂತಂದ್ರೆ ನಾವು ತುಂಬಾ ಅಪ್ರಾಕ್ಸಿಮೇಷನ್ ಮಾಡ್ಕೊಳ್ಳೋದು ನಿಮಗೆ ತುಂಬಾ ಟೈಮ್ ಕನ್ಸ್ಯೂಮ್ ಆಗುತ್ತೆ. ಬೇರೆ ಕ್ವಶನ್ ಆನ್ಸರ್ ಮಾಡೋದಕ್ಕೆ ತುಂಬಾ ಟೈಮ್ ಆಗುತ್ತೆ. So the answer will be 63. Which of the following reactions, if carried out at constant temperature, is accompanied by major decrease in entropy? Okay, entropy is a measure of randomness of a system or disorderliness of a system, right? So it is like randomness of the system. So ಎಲ್ಲಿ number of molecules of gases ಜಾಸ್ತಿ ಆಗುತ್ತೆ ಅಲ್ಲಿ ನಾನು entropy ಜಾಸ್ತಿ ಆಗುತ್ತೆ. See here it is 1 mole of the gas is getting converted into 2 mole of the gas. So the entropy ಜಾಸ್ತಿ ಆಗ್ತಾ ಇದೆ. So more number of molecules means more decrease of freedom, more energy states, rotational, vibrational energy. So ಜಾಸ್ತಿ variety ಆಗುತ್ತೆ. Kinetic energy also increases therefore. And here it is 4 moles of the gases. 4 moles of the gas is becoming 2 moles. So ಇಲ್ಲಿ ನಮಗೆ entropy ಕಡಿಮೆ ಆಗ್ತದೆ. Entropy is decreasing in the second case because 4 moles of gases ಅಂದ್ರೆ ಜಾಸ್ತಿ molecules ಇದೆ, 2 moles of gases ಅಂದ್ರೆ molecules ಕಡಿಮೆ. In C, so 0 number of moles of reactants is becoming 1 mole of a gas. So initially there was no gas, therefore ಇಲ್ಲಿ increase the solid state ಅಲ್ಲಿ the liquid gaseous state ಬರ್ತಾ ಇದೆ. There will be more expansion, more number of molecules having high energy. Again here iodine solid anta ಕೊಟ್ಟಿದೆ. Therefore it is 1 mole of the gas is becoming 2 moles of the gas. So increases. Illu kuda entropy increases. So there is only one entropy decreases, that is in the 16th, that is the nitrogen formation of ammonia. Therefore that will be the answer. In each of the reactions will be always spontaneous. Then you have to recall the relation delta G is equal to delta H minus T into delta S. Delta G, if it is negative, then the reaction will be always spontaneous. That is the condition for spontaneity. It will be always spontaneous process. So delta H negative ಆಗಿದ್ರೆ delta S positive ಆಗಿದ್ರೆ then T delta S will be a negative value. Therefore, as a whole, if you add these two, it is like say minus 200 minus of another 100, then it will be 300. So it is, therefore, that value, that reaction will be always spontaneous. So delta H negative under exothermic reaction. Delta S positive ಅಂದ್ರೆ the reaction means randomness increases. So delta S positive, delta H negative ಇರುವಂತ ಆಪ್ಷನ್ ನಾವು ಚೂಸ್ ಮಾಡ್ತೀವಿ. Delta H negative, delta H negative, but delta S positive. Okay, C is the answer. C ನಲ್ಲಿ correct ಆಗಿದೆ answer. Delta H is negative, where the exothermic delta S is positive, greater than 0 is positive. So here is a question. Delta G naught is minus 20 kilojoule. So what will be the relation between the direction of the reaction, the extent of the reaction, and delta G naught? See, for a reaction at equilibrium, delta G naught is given as minus 2.303 RT to log of equilibrium constant. So this question may be considered as equilibrium question, but in NCERT it is given the thermodynamics topic. So very high negative value for the delta J naught is a very high negative value. That means K should be very high value, very high positive value. So because of delta D naught, a high negative value, you can see here minus 20,000 joule. K value should be very high positive value. High positive and last year was approximately like 10 to the power of 4, 10 to the power of 5 or one there value. This value. Then only you get this around 20,000 volts. That means reaction has almost completed. So it is almost completion of the reaction. So reaction almost mugdo there will be almost P and Q reactants 0 there. So that should be the correct statement. So that is the correct answer also. That is the correct statement. Finally, virtually no R and S center put together, but for the reverse reaction it is true. If delta G naught is a very high positive value, K will be very high negative value. And the reaction almost forward direction hogilla. So C and D, that cannot be the answers. If slightly greater than it comes by K will be very close to 1. So Arston high value varala delta G naught. So we can rule out log K almost same then the log K will be equal to 1 log of 1 and the 0. Delta G naught becomes 0 if it is very nearly same. In case of the last one, see logarithm of 1 and the log of 1 will be 0. So delta G naught is also 0. So correct answer is there is no P and Q, and almost all the reactants are converted into the products. In which of the following processes entropy decreases? In mixing up of the gases, say you have two chambers containing nitrogen and hydrogen in same temperature, same volume vessel. ಈಗ ಇಲ್ಲೆಲ್ಲ ಬರೀ nitrogen molecules ಇದೆ, whereas in other there are only hydrogen molecules. So when you create a small hole here, so the molecules move from one chamber to another chamber. Therefore, they get more freedom. So hydrogen molecules ಕೆಲವೆಲ್ಲ nitrogen chamber. Similarly, nitrogen molecules, some of them they go to the hydrogen chamber. Therefore, mixing up of the gases gives more freedom. So disorderliness increases. Similarly, disorderliness entropy just there. Diffusion of a gas means movement of gas from high concentration region to lower concentration region, like smoke getting spread from a cigarette or an incense stick. Spread. So here also it spreads, it increases. Freezing of water. Freezing of water, in liquid state ಅಲ್ಲಿ water ಗೆ ಸ್ವಲ್ಪನಾದ್ರೂ movement ಇರುತ್ತೆ. Slightly H2O molecules are moving. But once it becomes a solid, there will be tight packing of water molecules in a crystal. So there will be no linear motion and rotatory motion. Slight vibration ಮಾತ್ರ ಇರುತ್ತೆ molecules ಗೆ. They will be vibrating even at the mean position. So here the entropy decreases. In freezing of water from liquid state to solid state, we decrease in entropy. The operation of a liquid also increases entropy because in gaseous state there will be more freedom, decrease of freedom. So in 3 cases entropy increases, whereas in freezing of water entropy decreases. Always conversion of gas to liquid or liquid to gas leads to decrease in entropy. So that's all for today. Okay. Thank you all. Thank you very much for listening.